Hello, and this is Calculus with Mr. Allenson. Today we're going to be doing problem number 1 from the 2004 BC test. Starts out with a traffic flow problem where there's a function f that tells you the rate that the traffic is flowing through the intersection. So A says, to the nearest whole number, how many cars pass through the intersection over the 30-minute period, so 0 to 30. So I'm going to integrate from 0 to 30 the function, the rate function, with respect to time. And I'm going to get 2,474 cars. B says, is the traffic flow increasing or decreasing at t equals 7, and give a reason. So is the rate increasing or decreasing? F of t is a rate of flow, and is that rate increasing? So I want to take the second derivative, or essentially the first derivative of the rate, and I don't have to take the whole thing. I just really want to find f prime of 7. And so when I take f prime of 7, I'll get negative 1.872 or negative 1.873. And since f prime of 7 is less than 0, traffic flow is decreasing. C says, what is the average value of traffic flow from the interval 10 to 15, and indicate units of measure. So average value of a function, 1 over 15 minus 10 times the integral from 10 to 15 of f of t dt, which is 81.899. And average value of the function, this function f of t tells you cars per minute, so this is in cars per minute. D says, what is the average rate of change? Average rate of change is average slope of the function from 10 to 15, and so that would be f of 15 minus f of 10 over 15 minus 10, which is 1.517 or 1.518, and that's going to be in cars per minute squared because it's the rate that the rate is changing. So points for this one, 3 points for A, 1 for the limits, 1 for the integrand, and 1 for the answer. B, 1 for the answer with a reason. C, 1 point for the limits, 1 for the integrand, 1 for the answer, and D, 1 point for the answer. And there's also 1 additional point for C and D to both have the correct units.